Well, good evening, everyone. Welcome to our Curious Minds talk. Sorry for the slightly little late start. We had to overcome some technical difficulties, but we're all in business now. So the talk this evening, we've got a guest from Dundee University, Forensic Science. Now, those of you who've been following the series for a few years will remember a few years back we had Niamh McDeed give a talk in Perth. She talked about her work. And so when she left, I said, well, would you like to come back sometime maybe and tell us about some real cases, some real work that your institute are doing? And so she passed her request on to Craig, who's very kindly joining us this evening. Now, I should tell you a little bit about Craig. Oh, he'll introduce himself, but one of the most important things is that today was his last day of work. He is starting a new job in Norway, and right now, if you could see what's off to his left shoulder, he's got a pile of removals boxes. So he is actually physically in the act of moving from Dundee to Norway. So we were kind of lucky to catch up with him in his temporary accommodation there. Anyway, so tonight, Craig's going to talk about detecting drugs in prisons. Serious subject, serious problems, both within the judicial environment, serious problems for the wider community outside. A problem that hopefully none of us will ever personally experience, but not so good for the people caught up in it. Before Craig starts, I will just say that our speaker next week is Nick Gardner from St Andrews University, and he's going to talk about the kind of origins of plate tectonics. Actually, the origins in terms of how plate tectonics work, but also the origins of the ideas and how long it took for the community to accept them. Now, the plan is for Nick to be speaking in the Suter Theatre. Of course, everything depends on our lovely COVID situation. We'll keep you informed, but the plan is to have a live talk next week. It'll also be on Zoom. Right, at this point, I'll hand you over to Craig, who's going to, well, entertain us for the next hour or so and have your questions already, as usual. Craig, thank you.
Okay, thank you very much. Thank you very much, everyone, for coming along on a Friday night. Thank you very much for the invitation to come and speak with you all tonight. I'm not quite finished yet. I think I've got 2 more days left to do in the Leverhulme Research Centre, but my work continues with them after I leave to Norway. So I'm carrying on with some of the work that I'm going to be presenting today. So yes, it's been fairly involved. So I'll just make everything clear, and then I will share my slides with you. And I welcome any questions that you may have at the end of the presentation. I hope you find it very interesting. It may be eye-opening. That's what I've heard before. If I've given this, people didn't quite realize what the issues were. So my name is Dr. Craig Mackenzie. I am currently, for another few days, principal investigator at the Leverhulme Research Centre for Forensic Science. I'm a former forensic scientist for the Scottish Forensic Science Service, or Forensic Services. And, let's go to that. My apologies. So, what I'm going to talk to you today is a little bit of a continuation of what I used to do, which is drug analysis and forensic toxicology. And what I'm going to talk to you today about is the drug analysis side of things. So if I can just start by giving a bit of a plan or an overview, but also that I want to highlight a few things that if you're interested in what I say and you want to learn a bit more, then I have some recommendations. I don't normally do this, but there was an excellent news report that some of you may have seen or may not have seen on ITV recently. And I've put a YouTube link on there, but just type in Peter A. Smith, ITV, Barlinnie Prison. It was an excellent overview of what's going on. There's also a couple of books which is talking about these new drugs. We might have an idea what we mean by illicit or illegal drugs, but everything has changed a lot in the last 5 or 10 years. So if it is of interest to you, then there's some recommended reading. Very entertaining reads, but very informative. So I'm just going to talk to you about what I'm going to talk about. And this whack-a-mole game that you see on the image at the side is going to become very, very important in my talk. So we're going to talk about what we mean when we talk about drugs. And I'm not going to patronize everyone, but things have changed a lot. So I want to tell you what I mean when I talk about illicit drugs. And then I'm going to talk about what we refer to as new psychoactive substances. For years, these were known as legal highs. I also want to highlight that they are not legal. And that's the big thing. Okay, so things have changed and moved on a great deal. So you may be aware of the term legal highs. In fact, you may have had some of the shops in your towns or your cities that you may have seen. Part two is really, everyone always asks me, why is it so difficult to stop drugs? So there's a type of getting into prisons. So why is it such a challenge, and which drugs? Because it's not as easy as you'd think to stop these kind of drugs coming in. I'll explain why. Next, I'll actually just talk about the most problematic drugs. Some of these you may have heard of, but there's synthetic cannabinoids is probably the biggest one, and that's the nickname for that drug is Spice, and I'll explain why. We've got novel benzodiazepines, or benzo, street Valium, you may have heard quite a lot about. And then I'll talk about this drug whack-a-mole game. So as soon as you get one, another 10 pop up. So that's the challenge that we have to deal with. And then we're just going to discuss through the law of unintended consequences. Every time you ban something, something happens. And it's not always what you want it to happen. So we're going to talk about that. And then we're going to look at my crystal ball and look for some predictions and potential solutions. Then we're just going to conclude. Now, the one thing I really want to get over and speak to you today is I'm speaking on behalf of the Leverhulme Research Centre for Forensic Science. I collaborate very, very closely with my colleagues in the Scottish Prison Service and beyond, but I am not speaking on behalf of the Scottish Prison Service. I just want to let everyone that's being very clear, but we work very, very closely. I'm also not going to give any information away that would be a security risk or give any information that would help people get drugs into prisons. I think we're probably safe, but I just want to let you know that that's the caveat that I put on here. So I can't obviously share everything. So I just want to talk to you about what we're doing. So it's a Scottish Prisons non-judicial drug testing project. So I'm going to tell you a little bit about that. So I've been heading up that for a number of years with a load of my colleagues within LRCFS, the research centre I work in Dundee. And this is, the scope of this project is that we carry out non-judicial. So any drugs which are not going to be part of criminal proceedings. So that could be things which are sent in, so we don't know who sent them. We know who they were meant to be delivered to, but they can't be charged with that if someone sends them something. They just said, well, I didn't know, I didn't want them to be sent to me. So we're talking about where they're either small amounts, we need drug testing for intelligence because there's been some incidents around the prisons, or we're talking about mail coming into the prisons. And I'll go into a bit more detail. The scope of that was initially to look for what we call synthetic cannabinoids. I'll keep referring to them as Spice. Spice is the colloquial name for them. It doesn't have any real meaning. And the biggest problem with these drugs are being soaked into letters, children's drawings, cards. This has been going on for quite a long time, but it's now an extremely serious problem. We're going to look at benzodiazepine drugs. So benzodiazepine, probably the most commonly known one would be Valium or Xanax, lorazepam, these kind of things. But we're talking about a whole different set of drugs here, a whole different family. We call them novel benzodiazepines. So we see these, you might be curious when I put up that we detect them in clothing. and cards. So we're going to go into that, and that's some of the challenges that the prisons have to deal with. And then we're doing intelligence-led analysis. They get weird and wonderful things in. So therefore, we're talking about, well, what do we do? How do we handle things that could contain drugs, but we simply don't know? The project also ensures the on-site drug detection equipment remains fit for purpose, because these drugs are changing all the time. So we have to make sure that they can always detect them. We also provide harm reduction advice, because obviously these drugs are very harmful. They are being used, and we understand a lot about the issues around those. So we help the prison service with that. But we also share widely early warning data. Quite often we see drugs for the first time that nobody has ever seen anywhere else in the world in prisons, in Scotland as well. So we share that information across the world very rapidly. So the key project facts you might be interested for a kind of launch into the drugs and what we're talking about. It's been up and running since September 28. It was very small scale, and it started in collaboration with HMP Perth. So we really wanted to understand what was going on a small scale before we expanded it. So SPS, the Scottish Prison Service, supported that work, but we essentially funded it ourselves. They had a problem that we thought we could solve, and no one else had been able to solve it for them until we started speaking with them. So that ran until January 2021, and we got a lot of data, which I'll share with you, and that led us to really understand what was going on. So then we put a project proposal with the Scottish Prison Service to formally fund a 2-year project with a very clear set of goals. And now that we understood what the problem was, we had to work out how we were going to solve these problems together. So just to give you the scale of it, we've so far analysed over 1,400 drug seizures, so it's not 1 or 2. And individual seizures might have 3 or 4 different samples inside them that we test individually. So that's the scale of what we've been doing. So we do a full forensic examination, and we do a full chemical analysis. As we've mentioned, we've clearly seen that the most significant drug threats are synthetic cannabinoids and benzos or benzodiazepines. But I want to tell you a little bit about real concerns we have over very strong novel synthetic opioids. So if you think of morphine as a typical opioid or analgesic painkiller, some of these drugs are hundreds of times more stronger than morphine, and they can be soaked into paper, and they would be deadly. They're already killing a lot of people around the world, and they're also causing major concerns in the heroin market just now. So heroin being cut. You'll have heard of some of them, fentanyl analogs, and there's a whole opioid crisis in the United States at the moment. So we're keeping a very close eye on those novel synthetic opioids in our work. We're also doing large-scale independent assessments of the machines that the prisons use. There's no secrets, there's no giving anything away. If you've gone through an airport, maybe not recently, but where we could all travel easily, and your bag gets taken to the side, your bag would be swabbed by a little machine, and it's called an eye mobility spectrometer. So the ones that the prisons currently have are Rapid Scan Itemizer 3. And so we carried out an assessment to make sure that they were all working and they were fit for purpose. So that was the main project facts that I just wanted to give you. We also were asked to detect and confirm new concealment methods for benzodiazepines, because previously everyone thought the only major problem was synthetic cannabinoids, but there were new ways of getting benzodiazepines into prisons that were detected a couple of years ago. So we were asked to track that. So part 1 of this talk is really just about what we talk about when we talk about drugs. What do I mean by that? Because it might be different from what you mean, what you think. And then what is a new psychoactive substance and why it's not a legal high. We cannot refer to them as that. That is a term that has absolutely no meaning and actually suggests that these drugs are probably not that dangerous. And then, they don't have to be controlled by law. They do, and they are very, very dangerous. So I just put up a slide here which gives you an idea of what I refer to as the classic drugs. When I was in the forensic laboratory, this was kind of the majority of stuff I used to see day to day coming into the lab. So we've got the cannabis related drugs. Maybe you've heard of some of them, but not others. So butane hash oil, dabs, that's a way of extracting the active ingredients from the plant material. But probably the most common versions of that are herbal cannabis and cannabis resin. And they can vary quite widely in strength. And they've got a specific key active ingredient, which gives rise to most of the psychoactive effects. We've also got a major issue with either unprescribed and fake prescription medicines. So the biggest problem in Scotland is fake Valium tablets. But we've also got prescription medicines, which are not being prescribed to the person who's taken them. So diverted medicines, so gabapentin, pregabalin, Xanax, these kind of things. And then we've got the classics, the heroin, which is a mixture. Normally we have brown heroin in Scotland and most of the UK. So heroin is active ingredient is diamorphine, essentially, but it's mixed with caffeine, paracetamol, and various other things from the opium plant. And then we've got LSD, magic mushrooms, cocaine, crack cocaine, different types. And then what we call the classics. So amphetamine type substances. MDMA is ecstasy, and you can get in lots of different forms, methamphetamine. So that's what we classify as the classic. We really understand them. We understand how to analyze them, detect them. We understand the harms of those drugs. We also understand the market quite well. So there's apologies for this kind of text in the slides, but this will be available afterwards, obviously. But there's lots of definitions of new psychoactive substances. And one of them is that it's a substance in pure form or in a preparation not covered by the 1961 United Nations Single Convention, as amended by the later laws. So they are not controlled by international law. There are many different definitions of what those drugs are, but essentially they're drugs designed to mimic the classic drugs. That's what they've been designed to do. And normally they're a lot stronger. There's a lot of talk about these drugs in the media, and a lot of the media descriptions, legal highs, bath salts, spice, designer benzos, monkey dust. That was around as a kind of family of drugs called cathinones. Zombie drugs, that's specifically aimed at synthetic cannabinoids because of the effect it has on some people. Okay, so that's that's the definition of a new psychoactive substance. So these are lab synthesized drugs. So when I talk about synthetic cannabinoids, I don't mean synthetic cannabis. I mean synthetic cannabinoids. They've been made in a drug lab. They've never been near a plant. They are complete chemicals. They're not of plant origin, and they're often very high strength, or what we refer to as high potency substances. So what I've given you is a photograph of something I took a couple of years ago on my mobile phone. So I could have gone on my WhatsApp, my Twitter, or Skype, and I could have ordered that bag of drugs from a Chinese drugs lab. And it would have been sent to me by DHL or something else. That's how easy we're talking about now. It could be a very high, and I don't know actually what the drug is. I know what they told me what it is. But I can use social media, I can use my mobile phone, I can use my computer. I don't have to go and buy that drug on the street. So that's a typical sign of new psychoactive substances. Just to give you an idea of the scale of it, remembering we probably only had about 30 or 40 main drugs previously. We're now dealing with over 1,000 new drugs, 1,000 different substances since 2005. It's kind of mind-blowing to think that we had cannabis and heroin and cocaine for so many years to deal with, and now we're dealing with over 1,000 new substances. We don't see those 1,000 substances all the time, and we don't see them everywhere. So 830 of those drugs were detected in Europe. And just to give you an idea, the numbers of drugs being detected are actually going down in the last couple of years each year. But essentially, a new illicit drug is being detected, has been detected nearly once a week. And then we have to try and detect it. We have to work out how toxic it is. So that's quite a challenge to us as forensic scientists. We have to deal with that level of change. So where we used to get in the lab, it was you come in the morning and go, well, I've probably got cocaine, I've probably got cannabis or heroin. Now you get unknown white powders and strange substances. You have to figure out what the drug is. You have no idea how toxic it is, what the effect is, and you have to deal with that. So that's the biggest issue. We've got very little information about the effect. So people are taking these drugs. It's almost like a human experiment. Nobody actually knows half the time what the effects are likely to be. We don't know how potent they are, their relative strength, so we don't know how dangerous they are. We don't know what happens to them once someone takes them. Where do they go in the body? What are the long-term and short-term effects of those? So a very worrying trend. We can understand and we can predict those effects through our research. But that's not something I'll be talking about this evening. So in Europe, we had 46 MPS detected in 2020, 830 are being actively monitored, and there were 400 basically circulating on the drug market that were available to buy for people to buy up through their computers. And we get this kind of information from, as I said, we share lots of information with each other. And this is from the European Drug Report. Just to give you an idea of the breakdown of what kind of chemicals we see, out of the 830, 209, the largest group are cannabinoids. And that is synthetic cannabinoids, which I'm going to talk to you about today. They are the most common group. Cathinones, so cat is a naturally occurring drug, but these are the synthetic versions of it. And lots of other substances, benzodiazepines, phenethylamines are ecstasy type drugs. So there are hundreds of these different types of drugs. They all belong to different families and they all have different effects. Just to give you an idea of the timescales, it's very hard to see this on the screen, but just to show you that you can see the top bar graph is the number of all substances being detected each year. So there was a high point around 2014-15, and then it started to reduce. But that doesn't mean the problem's gone away. It just means that there are less different drugs, but the drugs which are there are probably much more harmful. In the cannabinoids, you can see the same kind of pattern, but of great concern is the opioids. So those are the very potent, very dangerous, likely to cause very serious harms and death. They have been increasing in number and they've been increasing in potency. So that's what we have to really keep an eye out for. So I just give you this information so when I start talking about what we're seeing in prisons, that we can then understand what I'm talking about and the dangers of these compounds and how we have to deal with them. So I'm going to be quite generalized here, but new psychoactive substances, or MPS, generally have been legally synthesized in the People's Republic of China. So under Chinese law, when they're synthesized, it has not been illegal to synthesize them. So drugs labs will be making these. They then sell them online, and then they're sent around the world using the global mail system. As soon as a drug becomes controlled internationally, they become illegal in China, and China is doing a great deal of work to try and stop this. But that's probably the majority of the drugs, those very novel new drugs, were coming from People's Republic of China. There are other places where they come from. And so China also, so as well as these drugs being controlled internationally, China signs up to those international protocols, their drugs can also be banned just unilaterally by China themselves. And in doing this, this can actually create this whack-a-mole system, and I'll explain why. So if we look at what China did originally, it took, in October 2015, it took 116 of the most harmful of those new drugs and banned them. It named them individually and drew their chemical structures. And how the market reacted was exactly how you would expect to react. They looked at the chemical structures of all the ones that were banned, and they simply changed it a tiny little bit to get around the ban, and it still had the same effect, and it still was as harmful. So we've got this whack-a-mole. You ban one drug, they just tweak the chemical structure, and you suddenly get another drug about 2 minutes later appearing on the street. So you can never win, really. So in March 2017, they banned the most potent of those fentanyl analogs, those opioids. And in August 2018, they banned another set of MPS. And that's quite important for the prisons, and I'll come back to that. But now they take a different approach because they could see all they were doing was they were creating market diversity. So just as we get used to one drug and we understand it, it suddenly disappeared and we had to work out what the hell was going on with another drug. So a real big problem for us. And so what they did was they did what our legislation does in the UK, is that they banned on the chemical structure family. So all the very similar drugs that have a very similar chemical structure were all banned at the same time. So in May 2019, fentanyl designer analogs, so that's all the different versions of fentanyl, there could be hundreds of possible versions, they were all banned. And they pretty much disappeared until recently. Then just recently, the synthetic cannabinoid receptor agonists were all banned, the spice drugs. And predictably, it's taking a while to take effect, but those drugs are starting to change. So we know that in the prisons, where we see a lot of those synthetic cannabinoids, we're going to start seeing a big change in the market very soon. So we're going to get a whole load of strange effects, strange presentations. We have to make sure that we can still detect them. So the big thing I want to get over to you is actually what controls what we see in prisons in Scotland is whether or not the drugs are banned in China. And it's quite a strange way to think about that. If it's banned in China, it'll probably disappear from our prisons in 3 months. So our drug legislation does not really affect supply in terms of the drugs that we actually see. And I'll explain a little bit about that. So here's typical legal highs that used to be in the head shop. So new psychoactive substances are not legal highs. Most of them are internationally controlled, or many of them are. The majority are controlled as Class A, B, or C drugs under the Misuse of Drugs Act. And if they're not controlled under the Misuse of Drugs Act, they're controlled under some newer legislation called the Psychoactive Substances Act. So if it is psychoactive, it is a controlled drug. Okay. And so when we had the head shops, you used to get all the drugs being sold in these really bright packaging, appealing to a younger market. And you never knew what you were buying. So then trading standards legislation and that Psychoactive Substance Act were applied, which led to the closure of those high street head shops, they were called. And I know there were some in Perth, there were some in Tayside, Angus, there were several shops, and they all got closed down. Basically, everything moved online. So now those drugs are bought and sold on the clear web, so what you could just log into without any problem that you would be detected, or dark web online marketplaces. You can also buy the drugs via social media. So you would link directly to a network of drug supply, and you can just do it through your computer. And they're posted to the buyer through international mail distribution networks and very anonymous looking packages, and normally stickers on everything saying not for human consumption, or they've just been hidden, so you don't know what's in the package. So you're kind of trusting that what you've been sent is actually what you ordered, and these drugs could kill you. So it's a little bit, you're putting your life in someone else's hands, so good luck with that. So this is an example. So you can connect with sellers on WhatsApp, Twitter, Skype, Facebook, Snapchat, TikTok, dark web, whatever you want to do. And here's a couple of snapshots from the web for 4FADB, which is a synthetic cannabinoid, and it's listing what you can buy in Germany, because this is a German website, all the listing of all the drugs you can buy from this website. It's basically just like Amazon. You can buy all the drugs off of it. Then you've got Twitter feeds at the bottom, and that's, I just typed in 4FADB into Twitter, and it gave me a load of people trying to sell it to me. Of course, your behavior online is quite often tracked. So if you just start looking for this stuff, it's not entirely anonymous. And you can see a WhatsApp message there, Wicker, and this is people offering to sell. There's photographs of all bags of drugs, probably in the Chinese drug laboratory. So just to give you an idea of what we're dealing with when we're talking about new psychoactive substances. Equally, you can go online and we're clear web and dark web, so surface web, where you could just use Google. And if you go into Reddit, which is a website, reddit.com, and type Reddit noids, you can get everyone talking about synthetic cannabinoids. And they're basically reviewing the drugs, saying what drugs were good, what drugs were bad. And so they're talking about what the effects were, how much they should take, how to make it, how to impregnate it into paper. And this is all openly discussed online. So, hey, after this talk, if you're interested, enter another world. It's basically like an Amazon review list for illegal drugs on the clear web. And there's online fora. And actually, one of the really good things about those websites is it actually provides harm reduction. If someone has taken something that's really awful, they will try to warn everyone. So it's not all negative. It's actually got a positive community sharing about keeping people safe. So this is basically people talking about, all the different discussions. And you can see there were people commenting on the different discussions, there's message boards. So there's a whole culture about these drugs online. So where do they come from? So if we talk about synthetic cannabinoids, they all come from research, probably the late 70s, early 80s. And when people published an academic paper, it kind of sat in a library, it wasn't that accessible. This is a paper that was looking at making cannabis mimics, because cannabis actually has some very positive effects, but they were trying to remove the psychoactivity and have them as analgesics and all the positive reported effects of cannabis. And so they were making all these drugs and they were telling everyone how to make them and saying how strong they were, and they were publishing them in academic journals. And you could go online right now and you could look at that journal, it tells you how to make the drugs. And then you've got patents. So this is a Pfizer patent. Patents all get posted online when pharmaceutical companies make a drug. And this drug, this is the patent for about 300 different drugs. And these are actually the drugs we now see in our prisons, because it teaches everyone how to make it and it tells everyone which ones are the strongest ones to make. So that's a Pfizer patent from 2009, and that's the source of the drugs I'm going to tell you about. And I've even given you a link so you can find out. You can have a look at the Pfizer patent. So everything was published, and now we've got the internet. Everyone can look all these drugs up and they can mimic them. And if people are very good synthetic chemists and they work in a lab, they could make those drugs. So we have to be very careful about what we publish, because our papers are discussed about half an hour after they get posted on drug user forums. It's quite interesting to see what they say about your work. So it's instant feedback, I guess. So that's a little bit about MPS. So now about prisons. So why is it so difficult to stop drugs getting into prisons? So why are they such a challenge? So I'll go through this. So the traditional methods of getting drugs into prisons are via visitors who bring them in, secreted on their bodies or inside their bodies. Concealment in items which are sent into the prison. So you can see here, the image I've shown you is actually Itizolam blotters. So that is designer of Valium. It's much stronger, and it's been impregnated into blotters, which are then stuck under the tongue. It's in a gift tag, and it's been stuck down and glued. So that's concealment. There are many concealment methods. I'm not going to share all those with everyone. I'm sure you're not going to be sending drugs into prisons, but if for security reasons, I'm quite careful about that. Or drugs are thrown over the wall. And there's lots of stories of all the different ways that happens. So that's the traditional way of getting drugs into prisons. And so we've got 15 prisons in Scotland, spread throughout the country. And we know that there's a synthetic cannabinoid problem. And as well as being harmful, then synthetic cannabinoids actually are very unpredictable. So prisoners can get very violent or they could be catatonic. You simply don't know what way it's going to go because it depends on the dose. So Scottish Prison Service said there was a 44% increase in serious injury and prisoner assaults. There was an increase in assaults on staff, and it's clearly thought that there is an increase in, this is down to drug use and drug importation into the prisons. And we know from our work and from elsewhere in the country that these prisons are largely entering through the mail system, and they're invisible. And there's been lots of newspapers reports and media reports quite rightly about this problem. And so the SPS, the Scottish Prison Service, have been extremely proactive in trying to work out how they can stop this happening, how they can protect their prisoners, because they obviously have a duty of care that they take very seriously. These drugs are very harmful and very unpredictable. And so this is talked about a lot in the media. So another thing that had a big effect was the prison smoking ban. Because of the effects of secondhand smoke and trying to discourage smoking, a smoking ban came into effect in December 2018. So all prisons are smoke-free. Prisoners were given electronic smoking devices, so e-cigarettes were allowed. And that changed how the drugs were being used. So previously drugs were coming in kind of herbal form. So the drugs were dissolved, bought online, dissolved in nail varnish remover or alcohol, normally vodka, because it's colorless and doesn't have a smell, soaked into herbal material so it looked like herbal cannabis. But you couldn't get tobacco anymore in the prisons, so they had to change the tactics. So they started to impregnate it into paper. So they stick the pieces of paper, they dismantle the e-cigarette and they get the heating coil and they stick the piece of paper against the heating coil and then they take in the drug using an e-cigarette. So that changed the way the drugs were being used. Law of unintended consequences. So right at the bottom, you can see pipes made out of milk bottles for taking these drugs. And you can see typical dosage units. Those little pieces of paper have been torn up and they're pushed into the electronic cigarette. So why are they so prevalent? Well, they're very highly potent, so you only need very, very small amounts, so it's very easy to hide. If you can't see the drug, it's very difficult to stop it coming into the prison. It makes them very unpredictable then, because you don't know what the drug is, and the drug is likely to be extremely toxic or harmful. So prisoners, you literally don't know what's going to happen when you take it. So because you only need a low concentration, you can soak it into paper and card, and that piece of paper or card will have a much stronger psychoactive effect than you would ever imagine from a normal traditional drug. Because you can infuse it into paper and card and clothing, then it's completely invisible. So we need to be working really hard to pick those up. And because some drugs were successful for a long time because the detection mechanisms weren't in place, that's become a culture of infusing drugs into materials now to get them into prisons. So it's perceived to be very difficult to take these drugs in urine tests. It's not, but you need to know what you're doing. And these synthetic cannabinoids are easy to vape. By vaping the drug, it makes them much more harmful. So I'm just going to give you examples of why it's so hard. When people say, well, why don't they stop drugs coming to prison? It should be easy. Well, they get hundreds of items of mail a day into all the prisons. And here we have a letter, just looks like a normal letter. Those cuts are just to anonymize the letter, and the cuts at the edges are us taking samples. So that piece of paper contains a large amount of 4 different synthetic cannabinoids, and I've given you the chemical names. Could you tell they had the drugs infused into them? Good luck with that. And hundreds of these letters are coming in every day. Here's a sock. And we get many socks and underpants and towels. You just think that looks like a sock. That sock has been soaked in a potent benzodiazepine called atizolam. Can you tell? So the prisons are meant to be able to stop this coming in. Here's a greetings card. You can read the message, because that's a little message telling someone that there is drugs in the card. So only weeks to go, my brother, here's a wee canteen on me. That's a message saying there's drugs in the card. That card is infused with benzodiazepines, again, etizolam, clonazepam, chemically related to diazepam. Could you tell that had drugs in it? Probably not. So that gives you an idea of what prisons are having to deal with. Very potent drugs, invisible to the eye, being sent in mail, very difficult to detect. So I'll talk through some of the drugs that we're looking at. So how they detected, and again, I have to be careful about what I do share, but a lot of the information I have is in the public realm anyway, I'm going to share with you. So the prisons scan incoming mail suspected of being infused with drugs. They physically search incoming mail items when required, and obviously there's issues around the legality of that. And I'm not going to talk about that. That's an issue for the Scottish Prison Service. And the scanning of suspicious items recovered in cell searches. So if something looks like it's being used for drugs, it gets recovered, and also from prisoners themselves. And then we do laboratory analysis of these non-judicial drug seizures. So I'm going to get a little bit technical here, but these are the techniques that we use. So eye mobility spectrometry, these are the instruments that you see in airports all the time when they swab your bags. There's gas chromatography mass spec. GCMS is like our workhorse. That would never be in a prison. That's always in a laboratory. The only one of these that are in a prison is the IMS, eye mobility spectrometer. Then we use the very expensive equipment to confirm or decide whether or not we've got a new drug that nobody has ever seen before. And that's very expensive and very specialist. So they're the kind of equipment that we're using to detect these drugs. So there are many ways to detect drugs, but this is one of them, is the use of ion trap mobility spectrometers, these airport type scanners. They have devices like this in every prison. They're very common in prisons in England and Wales. And the same types of devices are used in airports for drug detection and explosives detection. And they alarm if a drug is detected. They're very simple. You don't have to be a scientist. It just tells you if the drug is there. Super fast, it takes about 5 seconds, and there's no sample prep. So they can just be analyzed by a non-scientific person. And often those positives are sent to us for further lab testing. So that's not giving anything away. It's well known, it's been all over the papers that those systems are being used. But we're not going to tell you about how they work and how they're maintained. So if we do it in the lab, then we've got the same machines, and we work out from all the different machines exactly what the drug is, whether it's controlled, if it's new, how harmful it is. But if we've never seen the drug before ever, and we have nothing to compare it to, we actually have to work out using quite high-end scientific equipment exactly what the drug is. And so we use high-resolution mass spectrometry, and we use nuclear magnetic resonance spectroscopy, so NMR. So just for those of you who might have a scientific background, we're using some high-end techniques. They're very expensive. These are the drugs we detect. I'll just give you a moment to take this in. You might recognize some of them. Some of them might are very common. Some of them are prescription drugs. And some of them we see some only once or twice, and some of them we see a lot of. And you can imagine the prisoners have a range of medical issues and mental health issues, and so that makes sense that you would see some of these drugs circulating in prisons. And a lot of these will be prescribed to them, and then they might be spread around the prison. So just an idea of the range of drugs we see in our testing. So let's talk about spice. So in order to understand spice, we need to know about cannabis. So obviously cannabis comes from a plant, the cannabis sativa plant normally, but there are other forms. And the most prominent cannabinoids, but there are many, many cannabinoids, are THC, which is the main psychoactive ingredient, and CBD, which you'll hear a lot about, is not psychoactive as such, but has many purported health benefits. And the resin, the material that contains these drugs, are excreted in little hairs and glands, which are present if you look at the leaf on a microscope, and these excrete the resin. And so you collect the resin in order to, so either the plant material is smoked or you collect the resin and it's this brown resinous material. So that's what we mean when we talk about cannabis. And synthetic cannabinoids have nothing to do with the plant, but they're designed to mimic it. And the first synthetic cannabinoids that were made in medicinal research were mimicking the THC, basically. So how do they work? I'm not going to go into much detail, but you have receptors and brains. So this is where the drug binds to a receptor, and I'll talk about that in a minute, and it causes an effect. And there's two different cannabinoid receptors throughout your body. One is CB1, one is CB2. CB1 is responsible mainly for the psychoactivity. CB2 is the kind of medical health benefits that people see of it, the analgesia and immune response. And they're differently distributed around the body. We've then got the lock and key mechanism to explain how these drugs work. The drug is essentially the key. The receptor, for example, in your brain, is the lock. And if the drug is the right shape, it can fit into the lock and the key will turn. And then the key turning will create a load of biological effects. So people will get high, essentially. And I'm not going to go into more detail than that, but the drug has to be a certain shape and it has to fit within the receptor. And we have this terminology: if a drug binds and activates and causes an effect, we call it an agonist. If it binds but does not activate it, we call it an antagonist. So if someone has an overdose of an opioid, the opioid fills the drug receptor and has the opioid analgesic effects and could give someone an overdose. And in order to stop that happening, we give them an antagonist, which goes into the receptor, replaces the opioid, and makes the person come around again. So that's what we mean by agonist, antagonist. So prisons are actually designed in a lab to fit into those receptors. So they're much stronger than cannabis. They can be up to 300 times stronger than cannabis. And they're very active at low doses. They were first detected in 2008 on the drug market and first detected in prisons in England in 2011. So this is why it doesn't fit. So THC from just kind of happens to fit in that receptor, which causes the high, but synthetic cannabinoids were designed in a lab to fit perfectly inside the receptor. So they're much stronger. So yeah, we call SCRAs full agonists and THC partial agonists. So they've got weird names. So the first names that we used to see were named after the people who made them or the companies. So you saw JWH compounds or AM compounds. When they were sold in head shops, they had lots of kind of marketable names. Spice. If anyone's a sci-fi fan, Spice comes from June by Frank Herbert. It was a material that gave you amazing powers. The film's just come out. If you want to go and catch it, you'll learn the origins of the spice name. Then scientific naming system. So they split the drug into 4 different parts, and there's like a pseudo-scientific name that I could understand. And I've given each of the different parts of the molecule the different colors. And if you go through it, the red bit has got MDMB. It's got a tail at the end of the molecule, and that's got 5 carbons, so it's pentyl. And if you add all those bits together, you get these names: 5F-MDMB Pinaca. If I remove a nitrogen from the middle part, it changes from Pinaca to Pica. And if I shorten the length of the carbon chain at the bottom, I get a 4F-MDMB butyl Pinaca. So there's a kind of chemical naming process that goes on. And that just explains what I'm going to talk to you about now. So before the 2000s, we really only dealt with natural cannabinoids. Then in the early 2000s, we dealt with head shops, and we got these kind of chemicals which were mimicking the synthetic cannabinoids from the plants. And now we've got this. We've got weird and wonderful drugs which are very potent, being soaked into paper. They're not being sold in packages, and they're being vaped and smoked in prisons. So that's the evolution. These are seizures from Scottish prisons. Vape pens, you see the doses, you see the vape pens being made into pipes. Sudoku and crosswords being soaked with drugs is very popular. You can see the dosage unit there being squared up, and that'll be sold for a certain amount of money per square. At the bottom of my left-hand corner, that's a dosage unit. That's what's going to be stuck in. And you get lots of images and letters being torn up. And then at the end, we have a new development, which is synthetic cannabinoids appearing in blotters like LSD, but there's no markings and there's no indication of what that drug might be. So you've got no idea what the drug is, how strong it is, anything. So just to show this is a piece of paper. If we visualized it, you can see there's markings on it. And the red dots tell you how strong the drug is. So the darker the color tells you how strong the drug is. So the darker the red, the stronger the drug. So if someone was to cut that piece of paper up, if they took one of the light pieces of paper, they would have virtually no effect. If they took one of the red, well, they would have an effect on them. If they took the same piece of paper but got a dark red piece, they're probably on their way to hospital. And there's no way to know. So you can see some markings on that. So this is why this is really dangerous, because the concentration is not the same across the paper. So you have no idea what the concentration is that they're taking. So very, very dangerous. Highly potent drugs, you've no idea what you're taking, you've no idea what the concentration is. So apologies for if anyone gets fast enough to read the letter, there's some not very nice language on it. But again, this piece of paper, so the previous one was sprayed into the middle. You can see that the drug was sprayed into the middle and then came out. This one has been soaked and then hung up from one corner, and all the drug has gone and run to the bottom of it. So someone taking that very high concentration is likely to be having a very nasty effect. So if a piece of paper goes around a prison area, then you're going to get different effects from the same piece of paper. And that doesn't make any sense to a prison guard. You know, everyone's taking the same piece of paper, but they're all acting differently. So that's a major problem with these drugs. Very unpredictable. So we did it in the lab. We made drugs ourselves. We worked out how they were doing it. We made them. And what you can see quite clearly is if you hang the papers up, if you lay the paper flat, the concentration is around about roughly the same across the paper. But if you hang them up to dry, all the drug goes to the bottom. And if you're the unfortunate soul that gets the piece at the bottom, you're probably on your way to hospital or worse with that effect. So very unpredictable. So this is what we see on a machine when we scan it. That's the same piece of paper I showed you earlier. And on our machine in the lab, we get a series of peaks. And you can see each of those peaks represents an individual drug. So that's what's in the paper. That's what's being smoked by someone. And that paper may have completely different concentrations of drug at the bottom than it does at the top. So extremely dangerous. We monitor these drugs over time. So on the y-axis, on the vertical axis, there's the concentration of the drug. The time is along the bottom. So you can see here that the color represents each different drug. So we had all these blue drugs for a long time. And then there's the drugs represented by the blue dots were banned by the Chinese government. And it took about 3 months for those drugs to disappear, and a whole load of new drugs turned up after they banned them. So banning them had no effect. It just changed the type of drug that was appearing in the prison. So you can ban them as much as you like. If there's a way, they'll just turn up. And that causes problems because we had to be able to detect them. This is just a snapshot of everything we've ever analyzed in the prisons. So along the top is the number of positive detections of samples that were received. Along the bottom is the date by quarter. Along the right are the different chemicals that we've detected. And the darker the color of blue, the more prevalent that drug is. And you can see these waves. So back in 2018, a drug called 5-FMDMB Panaca was really common. Then the Chinese government banned it, and the drug gangs switched to a drug called 4-FMDMB Panaca, and then that was banned, and then we got a drug called MDMB-4AM Panaca. That's just been banned, and in December we started to see a new drug called ADB-Butanaca. They're all potent drugs, but as soon as you ban a drug, a new drug just appears. So if you wondered why it was so difficult for prisons to stop these drugs coming in, well, they're changing all the time. And our work is to help them understand what's going on. So our latest detections are 2 beautifully named drugs, and the one at the bottom we just call Puppy. And this has specifically been designed to get around the new Chinese legislation. So that drug is not banned in China. So we're expecting to see a lot of that drug soon. So for anyone who likes a chemical structure, the chemical structures are all kind of similar, and all they're doing is they're just moving bits of the molecules around to get around these drugs. I won't linger on that. It's not just a Scottish problem. So if you just focus on the lines, the darker the color means that drug was really common. And what I'm showing you here is urine samples from prisons in Germany, Scottish seized samples, and Welsh seized samples of drugs. And so all the different drugs are on the right-hand side. But if you just look at where the lines are, they're very common between the different countries. So this is a global market. It's not a Scottish problem. The drugs get made in China. They end up in America, Scotland, Wales, everywhere at the same time. And we all share this information with each other. So we're tracking internationally these drugs moving around the country so that we all get heads up and warnings about new drugs coming along before they arrive. So whoever sees it first shares that information with all the other laboratories and all the other prisons. So it's not just a Scottish problem. We've done a lot of work, and someone then took our work and then said, well, I wonder if they've got the same problem in Brazilian prisons. Lo and behold, they found exactly the same problem in prisons in Brazil. So this is not a Scottish issue. It's becoming very, very common across the world. It's a very easy way of getting drugs into prisons. So what drives the change? So UK legislation isn't really changing the drugs that we're seeing. It used to, but now pretty much all drugs are banned. So that's not the driver. In the United States, sometimes the drug legislation, if it's not banned, you just get new drugs appearing. But that's not really what's changing the drugs. We've got legislation. When China banned the drugs, these 8 drugs, they disappeared really quickly from our prisons. When the international community banned the drugs, they disappeared from the prisons. And when this very common drug called MDMA-4 and Panaca was banned, suddenly the new drugs turned up. So actually the legislation bans everything in the UK, so it has no effect on which drugs we see, essentially. What matters is the international legislation and the legislation in China. China's just banned, don't worry about all the chemical structures, but China just banned all synthetic cannabinoids. So they wrote, if your drug has this chemical structure, it's going to be banned. So all that's happened is the drugs labs looked at those chemical structures and went, well, if it's got a hydrogen in that position or a methyl group or whatever, then it's banned. So all they did was they stuck an oxygen in there instead, and now that drug is not banned. So that drug has now been detected in America just in the last couple of weeks. And we're expecting to see lots of different drugs. So all that happened by banning all the other drugs is a new family of drugs have started to appear, and we expect to see this in prison quite soon. This is another one. This is the puppy drug that we refer to as puppy. So the Chinese government banned this kind of chemical structure. And what they did was they looked at the chemical structure and they said, that's not banned in China. And they went, we just stick this here. And now we're starting to see those drugs appearing in Scottish prisons because it gets around the Chinese ban. So whenever you try and ban it, a new drug appears on the market. So we just go through. So conscious of time. So we're just going to talk about benzos briefly. So benzodiazepine drugs, they're highly prevalent. They are, in context, Scotland has the worst drugs-related death statistics in the world, pretty much. But not everyone measures it in the same way. But a major part of drug-related deaths in Scotland is the use of these highly prevalent street benzodiazepine tablets, which are made to look like Valium tablets, but actually they're not, and they're all mostly fake. And most of the drugs that we see in Scotland are these benzodiazepines. The most common one is a drug called atizolam. And if you look at the graph, you can see how common atizolam has become since 2015. So this is the drugs implicated in deaths in Scotland. And you see that heroin and morphine are always high, unfortunately. Methadone is high. But look at the green line. That's atizolam. That's a novel designer drug that is everywhere in Scotland, unfortunately. And they come in these tablets, and you don't know what the concentration is, you don't know what the drug is, and they're very cheap and people take lots of them. So they're example tablets that we detected in Scottish prisons. Those drugs are not the same. So if I said that Valium had a potency of 1, then Atizolam is about 5 to 10 times stronger. Xanax is about 10 to 20 times stronger. Flubromazolam, which has never been available for prescription, a designer drug, an MPS, is 40 times stronger than Valium. And flualprazolam is another designer drug, is 15 to 30 times. So you can imagine if you think you're taking a diazepam tablet, you take 5 of them, but you actually take a drug which is 40 times stronger, you're going to have a major problem. So a tablet that contains 10 milligram would have the same effect as a tablet that contains 1 milligram of atizolam, 0.5 milligrams of alprazolam. But you've no idea what's in the drug. 30 new benzodiazepines have been identified in Europe. So just like synthetic cannabis, there's lots of them. 3 are internationally controlled. So now that atizolam has been controlled, will we see it disappear, or will we see another drug appearing? So we see a lot of these in prisons. We didn't used to see a lot, but then we saw a very worrying development. We also monitored these tablets, and so we analyzed these tablets, and we thought it would just contain atizolam, but this contains phenacetin, which is a banned analgesic. So if you thought you were getting a benzodiazepine drug, you're also getting phenacetin. And this other tablet contains a benzodiazepine, but also contains melatonin, which is the sleep-regulating hormone. So that's an interesting one to find in your tablet. So we get these all the time. So you have no idea what's in these samples. So the risk for people taking these is the actual benzodiazepine present. The mass of drug can vary a lot, and we do a lot of that testing. We know how much it varies. The variability of the content, and the rogue batches. You might get some weird and wonderful things just turning up in the tablets. They're not made by a pharmacist or a pharmaceutical. They're made in the garage with a pill press illegally. There's no quality control. So these are also powdered. You can see these bags of powder. And these drugs are taken with lots of other drugs. And if you take these drugs with an opioid, you could get respiratory depression and have an overdose. And they are very dangerous once they're in prisons. And they become even more dangerous because we now see them being sold into clothing. Those clothing items are then boiled in kettles to try and extract the drug, and they drink what's called atizolam tea. So would you know those items contain drugs? Probably not. So if everyone keeps saying, well, how do these drugs get into prisons? Well, this is what the prisons are up against. You get these multiple large seizures. Now, of course, the stuff I'm showing you is the stuff that didn't get into the prison. It was seized. Okay, so these did not get through. So these are little tabs, little pieces of paper that have been soaked with atizolam. So we start to see these benzodiazepines in greeting cards, paper, from around December 2020, so just around Christmas time, and they were flooded with cards. And you'd find these kettles with pieces of paper in it, and mugs with pieces of paper and things like that. And they were always detecting benzos. So this is a very dangerous way to take a drug. You've no idea what the concentration is. You've no idea you're drinking it, so it has a different effect. So this is a recent development that has become quite well known. So just to wrap up, we know what is circulating, but what can we do to minimize the drug harm? So the work that we do, we really do understand now. Previously, we didn't really know what, excuse my language, the hell was going on. It was just very potent drugs, very strange effects. How do you stop these drugs coming in? Well, now through this project, we really do understand what's coming in. We can predict what's coming in the future. We can understand the effects we're seeing in prisoners if drugs get through. But we also know that whatever is done to stop the drugs, it's very highly adaptable. The market changes. So whatever you do to try and stop it, the market will react. And that's what you're dealing with here. So the issue here is that you can limit supply, but the market will just adapt around that after a while, but hopefully to less dangerous ways. But if you don't reduce the demand, then the market will continue to adapt and may get more dangerous. So the bigger issue here is to reduce the demand for these drugs. And that's a lot more complicated than reducing the supply. We know that those scanners are a very effective part of the supply reduction strategy. We know the mail is one of the major sources, and impregnating drugs into mail makes the drugs more dangerous. And those benzodiazepine-infused clothing and textiles are also, we can detect all these now, and we continue to detect them, but there's a very dangerous way to take a drug. You've no idea what the drug is, you've no idea what effect it's going to have, you don't know the dose. So this is what I call chaotic and dangerous drug use. And we're doing everything we can to reduce the supply of these to protect prisoners from these kinds of drugs. So conclusions, the approach taken by the Scottish Prison Service, University of Dundee, is highly regarded and valued, both nationally and internationally. We really do know what's going on in the prisons. We've got very detailed information on drugs circulating. We share that across the world. You put countermeasures in place to deal with emerging drug threats, and you have to keep doing countermeasures all the time. We know that we will identify drugs and emerging harms very quickly, but if we don't reduce the demand for drugs, that's the key, then you'll just always be trying to keep one step ahead. And we are one step ahead, but it's very, very hard work to do it. We've seen this very high-risk benzodiazepine use being used, especially when prisoners might be on opioid substitution therapy like methadone, buprenorphine. If you start mixing that with Valium, it's a very dangerous situation. So you get lots of harms, or Tizolam, or things like that. So for those of you who really like the scientific stuff, we publish lots of work on this. So I'm not giving you away lots of secrets tonight. We have published this. It is known about a lot of these works. And I'd just like to thank some of our partners that we work with across the University of Dundee, our colleagues in Manchester Metropolitan University, the Police Scotland, the Scottish Prison Service. We can't do this work on our own. So thank you very, very much for listening. I really appreciate it. Thank you.
Wow. Okay. Well, we've had a lot of talks, Craig. I mean, seriously, a lot of talks, a lot of really good talks over the years in this Curious Minds. But I have to say after this one, first of all, I had no idea about this. I knew what you were going to talk about, but I really honestly had no idea of the magnitude of the problem, the complexity. I had no idea about the Chinese connection. I'm kind of astonished, surprised, and impressed. I'll start with a question, and it's a question that maybe you're going to say that you're not qualified to answer. Yeah. Okay. Okay. So during your talk, I'd written down a comment actually, and you actually said it during the talk. The law of unintended consequences seems to rule here. No matter what you do, okay, it provokes an unintended and maybe even worse consequence.
Absolutely.
Okay? Yeah. So, right. So my question is this, and to what extent are our drug laws to blame for the problems in the prison? In other words, I lived for 10 years in Oregon, and at the end of our time there, they legalized cannabis. One of our friends is a grower, super nice guy. If drug laws were not so stringent, would there be such a huge problem?
I'll start off. I can give a general answer to that. There's a in drugs research circles. There's a phrase that's called the iron law of prohibition. That means if you ban a drug, the drug that replaces it will normally be much stronger and more harmful. So this is a controversial area. If you have a ready supply of cannabis, for example, would you see a supply of synthetic cannabinoids? That's the argument that you're putting up. I don't know what the effect is. Synthetic cannabinoids are still seen in areas where where natural cannabis is present, for example. I should also reiterate that the synthetic cannabinoids, the name is a misnomer. I couldn't go into too much into the effects. they don't really have the same effects as cannabinoids. They're so much stronger, so much harmful. They actually work like stimulants as well as cannabinoids. So in one person, they'll be catatonic, they'll just go. It's more like a heroin high. And others, it will make them like as if they were taking methamphetamine. So these drugs are particularly harmful. They're a class of their own. You don't know you're going to get a lot of violence. So there is an argument, and I won't give an opinion because of the nature of my work, but what I will say is, yes, there is an argument that if you didn't control the use of certain milder drugs, because the whole point of using these drugs was to get around detection in urine samples, because you could detect cannabis, it stays in your body for weeks, but these drugs don't. And that was one of the reasons why they appeared, because then people could take them without ever being detected. And so, yes, they are in response to drug prohibition. And then you start to ban them, and the drugs that started were harmful but relatively mild to what we've got now. And so it's always like that. So that's a long answer, and I didn't try to avoid the question, but yes, it's there are consequences to banning drugs, but you have to ban them because they're particularly harmful, so it's...
Okay, we have got a huge list of questions. Michael, how are we going to manage this? Can you see the questions on the chat?
Yes, I can. I'm suitably impressed.
How would you, so if you can see the questions, let's do this fairly quickly. Why don't you skim them, pick a question, answer it, and let's see how we get on,
Okay. So there's a question from David Bowler, I think it is. Apologies if I pronounced your name wrong. Is the Chinese forensic chemistry service actually quite efficient? It seems they're able to shut down new drugs. Well, the drugs laws in China are very, very strong. So they don't want to be seen as being the source of all these drugs. They want to clamp down, but this is where most of the fentanyl used to come from in America. It used to be sent over. But as soon as the Chinese government banned it, the fentanyl production in the United States moved to Mexico. So, they are very, very efficient. When a drug is banned in China, it tends to disappear very quickly. But the gangs and the labs and some of the legitimate laboratories are very good at identifying how to get around the ban. That's all I'll say. They're very good chemists, just like us. It's like basically chemists in combat with each other, if you can see it that way. There was a question there from Bob Thompson, a very good one. Can mail not be photocopied to avoid the original being consumed? Well, of course, that's...
I should interject. Can I interject? Bob Thompson is a friend of mine who used to be the Chief Constable of Loch Gelly. Isn't that right, Bob?
Well, that's a very good question. There are legal issues around opening prisoner mail and dealing with it. But yes, in certain places, you do photocopy the mail. So in Sweden, they do it. Certain prisons down south, they do that. But then you contaminate. You've got health and safety issues. You've got legal issues about opening mail. You get legal mail, which is fake legal mail. So it's not as simple as you think. But yes, that is one solution that's been looked at across the world in simple terms. But it's what happens if you do that, you just shift the problem somewhere else. So you'll get more throwovers, you'll get more concealments. But yes, it's a perfectly logical question to ask. But there are legal limits under the Scottish law and UK law about opening people's mails under certain circumstances. So we've got, just look down. Does drug use in prisons, this is from Claire Scanlon, does drug use in prisons mirror drug use in the community? Actually, no, not as much as you would think. Scotland has a major drug problem, as we all know, but you don't see spice, this synthetic cannabinoid, you just don't see it in the streets. What you see is heroin, pregabalin, gabapentin, street Valium, cocaine, and you'd see that especially the benzos now in prison. So benzos is starting, it's more that prisons are now reflecting the drug market outside of prisons with benzos, but synthetic cannabinoids are seen outside of prisons in England and Wales far more than they're seen in Scotland. They're very rarely seen on the street drugs. So they don't really reflect drug use outside the community, because I don't think people would choose to take spice if they had an alternative. It's because that's what's available to them. So just going through it, if it's okay for me to go through these questions like this.
Yeah, sure. I think that's the most efficient way.
Yeah. So there's Walgard Gilbraith, who pays to send the drugs in? And well, that depends. I mean, drug use, there's manipulation. It's a terrible situation for a lot of prisoners. A lot of prisoners are the victims of this as well. And it's a very complex situation. This is organized crime groups. This is it's a big business to get drugs into prison. So who pays and sends the drug in? How they're reimbursed? Like any other drug market, it's complex, and there are ways to do it. And there is bullying, there's manipulation of people. You can make a large profit if you do get these drugs into prison. So it's a market just like any other market, I think is the answer I would give to that one, if that's okay. Do I think, this is Colin Wilkes, do I think the violence in prison would increase or decrease with these drugs? I think it would just change. These particular drugs add a layer of chaos to the normal functioning of a prison operation. I have nothing but admiration for prison staff and prison officers, because they're dealing with things that they never signed up to deal with. I'm going to be very, very open and say I have nothing but admiration for what they're dealing with and trying to understand. They've got a duty of care to these people. So I can't really answer whether it would increase or decrease. It will just be different, I think, less chaotic. Okay. So I'm just looking here. Can prisoners be given or offered access to safer drugs to undermine the market? Under current UK drugs law, no. You've got opioid substitution, which does that for opioids, so methadone, buprenorphine, Subutex, the other forms, but not yet for the cannabinoids or for the benzodiazepines. So under current legislation, no, that's not possible. So Rosemary Drysdale, what is being done to reduce the demand? A huge amount. I cannot state enough how much great work is going on in prisons, because you've got people coming in with history of drug use, with very vulnerable people coming in a lot of the time, with multiple medical issues, both mental health issues, physical health issues. And I don't want to give the impression that the prisons are doing nothing here. They're doing a huge amount of work, both to try to stop these strange drugs coming in, and if they do come in, to discuss and talk about that use, but also this great system of recovery cafes. If you look at the ITV link that I sent you, the Peter A. Smith item on ITV News, that talks a lot about the recovery cafes, the great work that's been going on to reduce demand. That's not my area of expertise, but I know a lot of work is going on to reduce demand. There is a knowledge that you can't only focus on supply reduction. You have to focus on demand reduction, otherwise it's pointless.
Okay, that was fabulous.
Okay,
that's the questions. Well done. Yeah,
I'm gonna have a lie down.
Yeah, you must be exhausted at this point. Okay, so at this point in the evening, I'm going to ask. I'm going to ask Claire Scanlon to give a vote of thanks. I did ask her, but I haven't actually had a confirmation from her. And if Claire is not there, then David Bowler is in reserve to give a vote of thanks. So. Michael, if you can see Claire, and if she's nodding her head, please make her active. If not, David Bowler is there, and I can see him nodding his head. Claire, thank you.
Okay. Yeah, I've just appeared. Sorry, Craig, that was really fascinating. Thank you. I thought That's an interesting topic, but is that really of interest to a lot of people? And I think the answer to that has definitely been yes. We realise just how much people like yourself, but the prison staff, are having to contend with, and really on our behalf, for keeping public order. So I think it gives us a completely different view of how people are having to operate. So thank you very much for doing this. And we all wish you well with your new job and your move to Norway.
Yes, I'm totally not stressed. By moving house, moving job, it's all very relaxed.
No, I'm sure it will be absolutely fine. And hopefully we'll maybe see you another time in the future if you...
Yes. Of course, I would say that I am staying related to the Leverhulme Research Centre for Forensic Science, so I am still connected with that. I've still got 3 PhD students working on this work. We've put so much work, and this work continues. It's not about me, it's about the team. And if I can very briefly say a huge thanks to my team. For security reasons, I don't put all their names up, just for that, because they don't choose to have their name up. But I have a team of amazing researchers, and the team at the Scottish Prison Service are wonderful, and they're very committed to dealing with this problem. So thank you.
Yeah. Okay, and again, thank you very much, and perhaps yourself or one of your colleagues in future when there have been more developments. So it's a bit difficult to give a round of applause over...
We can all flap our hands around and...
Yeah, something like that. Again, thank you so much.
No, thank you, everyone. Thank you for giving up your time on Friday to listen to me. So,
no, it's been really interesting.
Thank you. Okay, take care, everyone. Have a lovely weekend.
Okay, thank you very much, Craig. Okay, everybody. Well, that was great. Next talk, Nick Gardner, Friday the 5th of November. That's Guy Fawkes night, isn't it? Bonfire night. That seems an appropriate night to have a story about plate tectonics, doesn't it? Yep, bonfire night. Anyway, hopefully we're going to be doing it live. Tickets are available. We'll see you then. Thank you.